What's up, everybody? So you may have seen some of my webinars and presentations with Photonics Media and other groups like that, and sometimes for those studies I have to make nanoparticles. I thought it might be cool to show you how we do that using precision chemistry and spectroscopy to both synthesize and then analyze those nanoparticles. And in this case we're going to look at gold nanoparticles. So the first step is to carefully create a boiling vortex just like so. Son of a bitch. Okay, so let's try this again, but now note that we have a reflection probe set up to monitor the color of this in real time as the nanoparticles form. So let's start by adding in a ½ ml of our gold concentrate there. Looks good. Then we'll also add in a ½ ml of our citrate, and watch how fast this happens. We get this color change very quickly. It starts to go clear from that yellow. And everything gets darker, and there's our nanoparticles. Very beautiful. So we'll let this go for a bit. If you want really good resonance at 785, you can also add a little bit of Montreal steak seasoning. I really like to put in just a dash of this, just like that, and that really gives it a little extra zazz. Analyzing these with a cuvette setup is super easy, and that's what we've got set up here. So we've got a broadband source, a deuterium halogen source that covers all the wavelengths we need, our cuvette holder, and then an HR2 spectrometer that's also covering all the wavelengths we need. And note that we have two batches here. We have one on the left that we made previously, and then the one we just made on the right. Now you want the color for these to essentially be like a good Sonoma cab, maybe like an 08 cab is what you're going for. If it's too red and like Kool-Aid, that's no good, and if it's too dark purple and starts to get murky, that's no good either. So let's take a look at these by putting in a little bit of solution. Okay, we have DI water as our reference in absorbance mode. This is absorbance mode in ocean view. There we go, look at that. So we're getting a nice peak location. Of course I get something on the screen there, let's rip that off. But we get a nice peak location right at, where is that? That's at 537 nanometers. So let's take a quick screenshot of that. So we've got that frozen. Now we'll check our other one. And note this is at a slightly higher wavelength now. So now we've moved up a few nanometers to where now we're at 547. So we've moved up 10 nanometers. So we can quickly characterize the location of these peaks by doing a quick absorbance scan using this broadband spectroscopy system, which is really useful to do quality control on nanoparticles or anything else you may be analyzing.